All right. Hi, everyone. Hello. Welcome to the third lecture for Calculus 1. So it's like a speed run. It'll be a speed run lecture. And we will be doing section 1.4, and which is specifically focusing on the exponential functions, function transformations, the vertical shift, the horizontal shift, whatever. This will be chapter 1, section 4. All right. And if you want the notes for it, the notes will also be available on the membership page. So I don't know if you can see the membership page right there. So circusadaman.com, you can see the membership page over there. And we will be uploading the notes over there. So first of all, function transformations. So what function so the base function, obviously the base function is y is equal to f of x, and few rules are there. We have a vertical shift where y is equal to f of x plus k. So this is a vertical shift, right? You know what vertical shift is? So it shifts vertical. Horizontal shift is y is equal to f of x minus h. So this tells us that the y is shifted, like the vertical shift is shifted by some steps k, either back or front. This will tell us that the x is shifted by some value h. And then reflection, so it's like a mirror reflection, reflection x-axis. The y is equal to minus f of x. If I have y is equal to f of x, the opposite would be minus f of x, right? So that's reflection about the x-axis. Reflection on y would be y is equal to f of minus x. And then we got the vertical stretch where y is equal to a times f of x, a is some constant, and horizontal stretch y would be f of x by a. So that's the horizontal stretch. We can do a few examples. Probably we're going to do one example for each. So let's say example 1. So this will be on the vertical shift, right? Vertical shift. So let's say given that f of x is equal to x squared, and obviously it's a vertical shift, right? Let's transform f of x equals x squared to f of x is equal to x squared plus 3. So now this x squared, this graph, because initially you have, let's say 0 0, now it's going to be 0 3. If you have, let's say 1 1, it's going to be 1 4. If you have, let's say 2 4, you're going to have 2 7, right? So it shifts by 3. It moves or increases the step counts by 3, right? Now we're going to do horizontal shift. Horizontal shift. As long as you know the general equation, everything is easy. If I say I can use the same example, f of x is x squared. If I say have f of x minus 2, then therefore I'm going to have x minus 2 whole square. So here x changes, right? If I have x squared plus 3, y changes. If I have x minus 2 whole square, x changes. If I have x minus 2 whole square plus 3, x also changes, y also changes, right? So obviously this will be a move 2 steps to the left, right? So it's going to move 2 steps to the left. So that is a, no, not 2 steps to the left, 2 steps to the right. It's going to move 2 steps to the right. If I have x plus 2, then it's going to move 2 steps to the left. We'll do another example, not another example, but a different example. Let's say reflection. So let's say f of x is equal to square root of x. Now I know that for reflection, I'm going to have y is equal to minus f of x. So this will just be y is equal to minus root of x, right? If let's say I have y is equal to f of x with the f of x being root x, then therefore if I have 4, 2, and now it's going to transform to 4 minus 2. If I have, let's say, 25, 5, I'm going to have 25 minus 5. If I have, let's say, 3 root 3, I'm going to have 3 minus root 3. Again, this is not an imaginary value. Like this won't be invalid. This is invalid. No, sorry. This is invalid. This is okay. This is invalid. Cool. Vertical stretch. Vertical stretch. If I have f of x is equal to x square, right? Then if I want to increase it by 3, if I want to do the vertical stretch by 3, I'm going to have y is equal to, let's say, 3f of x. That'll be 3x square. So this stretches or enlarges by 3, right? Enlarges by 3. If I have a vertical shrink, I'm going to have 1 by 3 f of x, or 1 by 3 x squared. This will shrink by a third. No, not shrinks by a third, enlarges by a third. Enlarges by 1/3, shrinks to 1 by 3. 1 by 3, the original, whatever. Cool. And then you have a horizontal stretch. So if I have a horizontal stretch, so if I have y is equal to f of x by 2, and if I say f of x being x squared, then I'm going to import this here. Like import the, instead of x squared, I'm going to have y is equal to f of x by 2 whole square. So which means this time I'm actually going to have x by 2 whole square, which is simply x squared by 4. Because here x is changing, right? So that's the horizontal. Horizontal, x changes. Vertical, y changes. Cool. And then absolute value function. Absolute value function. I'm pretty sure you know what absolute value function is. So it'll be x. So that is f of x. If I have, let's say, x being minus 5, minus 5 would be 5. 7 would be 7. So there is no, so when you draw the graph, actually, your graph will look like this, right? Then we have combinations of functions. So combinations of functions, if I have the combinations of functions. If I have f plus g of x, that is the same as f of x plus g of x. F minus g of x would be f of x minus g of x. If I have fg of x or fg x, so that is just simply f of x g of x. If I have f by g of x, that'll be f of x divided by g of x. So we can, let's say, for example, if I have f of x being x squared, g of x being 2x, then I'm going to have f plus g of x, which is obviously x squared plus 2x. If I have f minus g of x, then that is x squared minus 2x. Fg of x would be 2x cubed. And then if I have f of x by g of x, or f by g of x, So there is just simply x square divided by 2x. You can break that down, so it will be x by 2. Then you got the composite functions, the function compositions. Function compositions where, let's say, for example, if I have f g of x, it's just saying f of g of x. So I can use the same example, x square and 2x. So I'm going to have, actually, let's use a different example. So if f of x is x squared, now we're going to use the same example. G of x is 2x. So instead of, if I have f of g of x, now f of x is x squared. Instead of x squared, you're going to have f of 2x squared. So typically, you're actually going to have 2x whole square, which is 4x squared, because f of g of x, g of x is what? 2x. If f of x is x squared, f of 2x would be what? 2x whole square, right? We'll do another one. So another example. So if I have f of x being root x and g of x being x minus 3, then if I have f of g of x, you can also have g of f of x. You can. So it's taking f of x minus 3. So obviously, if f of x is root x, f of x minus 3 would be root of x minus 3. And x minus 3 must be greater than or equal to 0. Right? And then you got the heave side function, which is typically like a piecewise function. Then you got the growth, then you got the decay, then you got the exponentials and all that stuff. And this marks the end of entirety of chapter 1. Entirety of chapter 1 is finished. You can always recap them. You can always do examples of them. I'm pretty sure you know what book you're using. Make sure you try to do them again and again. But it should be pretty simple for you guys. Cool.